So we're going to ignore the judgment, and we're going to talk about the 4 types of random sampling that we get. So here's the situation. Here's the problem. You've got 50 people who attended a concert. This is how they're seated. Here's the stage. Okay. And the band wanted to know what people thought of the concert. And since it would be difficult to find and get opinions from all 50, they asked us to select 10 people from the crowd and get their opinions. Okay, and then come up with a general opinion. So remember from the last lesson, we want to randomly select the 10 people. Because doing this avoids, what's that word that we used? Bias. Okay. Okay, so the simple random sampling. Well, it's pretty simple. Okay. And remember, we're talking about we want to randomly select a group of 10. Okay, so a simple random sample represents a sampling method in which every possible group of 10 individuals in the population has an equal chance of being selected. So this is where you would just go from 1 to 50, select me 5 random. So maybe you get this, and you get this, and you get this, and you get this, and you get this. Okay? You see here the pros and cons. Pretty easy to implement. And it does avoid bias because you're selecting randomly. Okay? However, it may not be precise as other random sampling methods. Okay? Because there's no guarantee that it's going to be representative of the population. So that's pretty straightforward. What about the stratified? So the stratified would be divides the population into groups or strata. Of individuals who share common traits. They have something in common. Now, this is where statistics becomes a little bit of an art, because depending on the problem, how do you select your strata? Okay, the one that we did as an activity, it was pretty obvious because there were 5 different ethnicities. So it was easy just to say, okay, those are our 5 groups. We'll choose 1 from each group. How would you divide this into strata? Remember, we want, how many do we want? 10? How would you divide these into groups and then take a random sample or 2 from each group? Think about the problem. It's asking the opinion of the band. Okay? How could we group them so that their experience with the band would be very similar? By rows, right? Because chances are this group might have a different experience than this group, the one that's closer to the stage. So what we could do is we could say, okay, we're going to make 5 groups of the rows. And how many do I randomly select from each group to get 10? I have to randomly select 2. So then I would just go to this and say, okay, from the numbers 41 to 50, give you 2 random numbers, so maybe you get these.
And then in this next row, you get these. And then in this next row, you get these. Then maybe you get this. And then maybe that.
And you've got your 10. Okay? An advantage of this method, why this is such a good method, okay, is it ensures if we can group the population into certain strata, certain common characteristics or common traits, okay, that will lead to less bias because we're going to be getting to a more representative sample. Because like what happens if for some reason you decided to do a simple random sample and all 10 you got were here? Maybe that's not representative. Okay? Or all 10 you got were near the back. Maybe not representative. There's more than one way to group. We could have grouped by column. I could have done this and then etc. And randomly selected how many from each group? 1. Okay, that's another way to do it. Because maybe people on the ends have a different experience than people in the middle, regardless of whether they're at the front or back. Maybe. Okay. What are the cons? Well, you have to be able to establish the groups. Okay, that could be challenging. And it could also be more difficult to implement because, and this is kind of like the simple random sampling too, you're going to get a bunch of people spread out all over the audience and it could be hard to find them. Okay? Which is where cluster comes in. What do you do with cluster sampling? You group again, but you randomly select one of the groups and survey everybody in that group. Okay? So for example, what I could do here is I could say, okay, let's make the rows a group again. We can do this. So I've got 5 groups. I'm going to randomly select a number from 1 to 5. And whatever that number is, everybody in that row gets surveyed. So if I got the 4th row from the stage, I would do everybody in this one. And you've got your 10. We could have divided it into 10 columns, randomly chose 2 of the columns, and surveyed all 5 from each one to get our 10. That's another way to do it. Okay, so we're still grouping them, and they're called clusters. And the cluster sampling selects a sample by randomly choosing clusters and including all individuals of the selected clusters in the sample. So if you think about the difference, sometimes students have a difficulty understanding the difference between strata and cluster, stratified and cluster. With stratified, you're taking some individuals from all groups. But with cluster, you're taking all individuals from some groups. It is possible to do random sampling that involves both of them. Okay. So the Pro, it's actually more cost efficient to do. Okay? Because it's probably easier to get all the people in this row than run around the whole audience. Okay? So when the population's even bigger, it can be more cost efficient and time efficient. That's the biggest advantage of cluster random sampling. The con, okay, if there's a big difference between these groups, it may not be very precise. So you can kind of see that stratified, hard to implement, but get a good representative sample. Cluster, easier to implement, but may not get as good a representative sample. So it's a trade-off. Okay? And finally, systematic. This is where you're going to randomly select every nth people in the group until you get your sample size. Okay? So how do you figure that out? So just to start here, systematic random sampling represents the method of sampling. Randomly selects a sample of the population by randomly selecting one. No, that's not right. Make sure I got that right. One of K. And then every case, I should use an individual after. So how do you figure out what person to start with and how many you go until you select the next one? You take your sample size, 50, okay? I want 10. So I've got, think of it like you've got 5 groups of 10, okay? So that means we randomly select a number from 1 to 5, and then every 5th one after that. So I would randomly select, let's say I got 2, and then every 5th one after that would get me my sample up to 10. So 7, 12, 17, etc. And I get my 10. Again, this can be pretty easy to implement depending on how your population is spread out or how they're structured. Okay. If they are in sort of an organized manner, like rows and columns or in a line, it's easier. But usually that's only the best time to use it. Okay. Otherwise, you could be running all over the place again. So those are the 4 types. So let's just look at this final example. A social media marketing company has 1,000 employees, 800 female, 200 male. Company has offices in 10 cities across Canada. Each office has 100 employees in similar roles. We want to survey employees about job satisfaction. So you are going to get a sample, a random sample of 100 employees. Okay? How would we do this if we just wanted a simple random sample? Number them. Number of employees from what? 1 to 1,000. Randomly generate 100 numbers. That's pretty straightforward. Okay. I think you might do a stratify. This is where we want to group them. You want to group by gender? Sure.
Group by gender. Which means we would randomly select, randomly generate. No, I'm going to say select this time. We use a random generator too. Randomly select how many females?
80.
Because then it's the same
Proportion of the sample as it is of the population.
and therefore how many males? 20 males.
We could have grouped by city. There's 100 employees in each city, so how many would we get from each of the 10 cities? 10. Could do that.
Although you might use the city for cluster.
Because it actually, the numbers fit perfectly. You've got 10 cities of 100, randomly select one of the cities and survey everybody in that location. Okay.
By city. Randomly select one of 10 cities. Survey all in that city. That will get you your sample size.
And finally, systematic. How would we do systematic? Sorry? Well, we want to select every certain, but we've got to figure out how many of that there is so that we get up to 100. So remember, you take your sample size,
Your population size, divided by your sample size. And we get 10.
which means we're going to randomly choose a number from 1 to 10, and then pick that one and go every 10th one after. And that will get us up to 100. Okay?
So randomly select a number from 1 to 10. Survey that individual. And every 10th one after. That employee.
Okay? So you should be familiar with the 4 types of random sampling, how to go about implementing them, and at least one advantage and disadvantage of each. Okay?
I'm not gonna, no, sorry, at most one advantage. I'm not gonna ask you to list several.
I might say, give me an advantage of stratified random sampling. Give me a disadvantage of cluster random sampling.
Okay,